Now in this lesson we're going to talk about the dirty story of when science goes wrong. Can you actually trust science? Most surveys indicate that science is trusted more than politicians, journalists, almost anybody else, but is that fair? Should you trust these scientists? Well, recently there's been a big kerfuffle, what's called the replication crisis, where it's been shown that actually a large fraction of scientific research in some fields, maybe over 50%, cannot be trusted. This has been a major crisis in fields like psychology. It comes from many causes. There is some fraud, more usually it's scientists fooling themselves as well as other people. There's a big problem with correct but useless science. So what we're going to talk about is how bad is the situation, what causes it, how to recognize it, and hopefully how to avoid it. So here's how science is supposed to work. A brilliant, disinterested scientist is sitting somewhere, they read the literature and they come up with a hypothesis, an idea. They go and get funding somehow to pursue the idea, they do the research, whatever it is, and then they publish the result. Now, this is supposed to be good because scientists are generally not in it for the money. There are definitely better ways to make money than science. And also there are a number of checks built in. First of all, when you're reading literature, you will critically analyse things. You'll say, oh, I don't trust that paper, and that paper looks okay. To get funding, you'll typically have to get a grant, and that means that your peers will have to review your application saying, I don't think this makes sense, this is not a very good scientific program, whatever it might be. And then finally, to be published, your paper must be peer reviewed. So in principle, there are checks at 3 different locations here. However, that's clearly not working as well as it should be, because there's increasing data that in some fields there's a lot of dubious science out there. So the replication crisis is where the basic idea of replication is that if you do research, your paper should explain what you did in enough detail that someone else can go and replicate, redo the same experiment, and they should get the same answer, to within the statistical noise. But in principle, practice, not many replications happen. People don't tend to get rewarded for redoing someone else's experiment. They've got to do a new and exciting experiment of their own to get funding, jobs, and so on. So most experiments have never been replicated. People just have trusted that they did it right. But it's become clear that was rather misplaced. Now, the most dramatic results are in psychology and medical research. There have now been a number of systematic attempts to replicate large numbers of papers, and typically 50% or more fail replication. In some cases, only 25% of the papers actually seem to be replicated, which seems to indicate that over half of all the scientific research in these fields is actually false in some sense. Now, this has been found first of all in psychology. It's widespread in medical research, but it's been found in a number of other fields: education, economics, social science, biology. Now, the examples I'm giving in these notes are mostly coming from the book Science Fictions by Stuart Ritchie. Excellent book, highly recommended. So this crisis really came to a head in the field of psychology, in particular the field of priming research. Now, priming research, excuse me if I don't get this quite right because I'm not a psychologist, the idea was that you give people a subtle hint about some topic and that has rather big consequences down the track. The field arguably started with a classic 1996 experiment. A number of participants were given a test in one room. They were asked to pick out words from a jumble. And then they had to walk down the corridor to do another experiment. But the real test was actually the walk down the corridor. What they found is that these words they were trying to unjumble, some of them were exposed to words that were supposed to remind them of old age, words like old or grey or knitting or something like that, whereas other words were just random and had nothing particular to do with old age. And as they then walked down the corridor afterwards, people with stopwatches tracked how long it would take them to walk. And the published results said that people who'd been exposed to the old age reminiscent words, even though they weren't old age people themselves necessarily, walked slower down the corridor than people exposed to random words. So somehow the idea that they'd been primed to think of age, even though it was entirely subconscious, made them walk slowly. Now this result seemed dramatic, so it got a lot of attention, and a whole field of psychology, of priming studies built up around it, and many, many more experiments were done, all of which claiming different forms of priming. For example, in science education, people found that if female students were primed by reminders of, for example, how badly women do in maths problems, they then did worse in maths problems. And so there were lots of applications of the stuff. Unfortunately, it turns out not to be true. In 2012, an independent group tried to run the same experiment again, that is, expose people to different words and see how fast they walked down the corridor, and they discovered, with a bigger sample and better experimental technique, no result. There was no difference in the speed people walked down the corridor depending which words it happened. And it turned out the original experiment, the people who were the stopwatchers who were measuring how fast they were walking down knew which people had been given the old words as opposed to the random words, and probably some sort of subconscious bias meant that they were pressing their stopwatchers a bit differently and getting this difference in walking speeds. And a whole series of other applications have demolished essentially all the results in this whole field. It seems that priming either doesn't exist at all, or if it is a much, much smaller effect than anybody thought about. So a whole field of psychology with literally thousands of papers and hundreds of researchers, it's crap. Here's another prominent psychological result. This is research by Amy Cuddy, led to the second most watched TED Talk ever and a best-selling book. The idea was that if you power pose for 2 minutes before going out to do something, this is hands on hip, legs apart, looking confident, this somehow reinforced your self-confidence, and you therefore felt more confident, but also they would measure, for example, higher testosterone levels in you, and that you'd take greater financial risks and lower levels of the stress hormone cortisol. Very dramatic. A lot of people started doing this, doing the poses to get themselves hyped up before some crucial job interview or something like this. Except it failed to replicate. A 2015 independent study showed that people did feel more confident after standing in the power pose, but it made no difference to testosterone, financial risk, or cortisol levels. So that's psychology, and I could cite 100 other examples. Medical research seems to be pretty much as bad. I guess I'm just going to give you a couple of examples. Anesthesia awareness is a rare condition where people who are under anesthetic, so they're supposed to be unconscious and not feeling the pain, actually wake up and feel excruciating pain but can't move a muscle, so they can't say, I'm in pain. So it's a really nasty situation. 1990 studies showed that having an electrode attached to the skull with particular sensors and analysis could tell if people, it was called a bispectral index monitor, could tell if people had woken up but were still unable to move, which would then alert the surgeon that they need to do something about this. And it became very widely used in over 40 million operations, except that in a 2008 study, a much better controlled study once again, couldn't replicate it. They found that this method did not work. Likewise, treatment for strokes. There was research suggesting the best thing for patients to do in the days after a stroke is to get moving, sit up, stand, walk if they can. This made its way into many hospital guidelines, so the nurses and doctors would be told, they've had a stroke, get them up walking. But again, it didn't replicate. A large 2015 randomized trial showed that actually getting them up and walking around made things worse. So we've seen it's a problem in psychology, it's a problem in medicine, and it's certainly a problem in many other fields, economics, medical research, education research. How about physics? This is a course called Physics Future Leaders. We don't really know. There have not been, as far as I'm aware, any systematic surveys to check reproducibility. In psychology and medicine, there were some horrific examples. Everyone became aware of the problem and they started checking it. In physics, we've not had the bad examples, and so people have not started checking it. There are certainly some cases of these problems in physics, which we'll talk about. In general, physics has a good reputation. It's a reputation of being science done right. Often the psychologists and the medical researchers will look at, here's how physicists do things, that's the good thing. But it may be changing. Physics standards may be dropping because all the same pressures that we'll talk about in a moment that led to these problems in other fields are also present in physics. So we have to be very much on our guard. It certainly is a problem at some level in physics. What that level is unclear, and it could certainly get much worse unless we're very careful.